Well, ladies and gentlemen, I'm not sure if you knew it already, but your city is already smart. And you know why? Because you are here. You are in the right spot and they have hired you. Welcome to the Fuse Forward session. It's my pleasure to introduce you to the CEO of Fuse Forward, Mark Damm, and he's going to introduce his illustrious team to take it away for the next 60 minutes here at MISA BC. Mark.
Thank you very much. Welcome everyone to Fuse Forward, give you our Fuse Forward's presentation on Your City is Already Smart. What we'd like to do is let me give you a little background first off, who Fuse Forward is, and then I'll get into a few introductions of our speakers and the kind of content we're going to cover today. So Fuse Forward, we're proud to be a sponsor of MISA. We've been working with local governments for over 25 years. And as part of that, what we have is we've been working with organizations all through BC, Ontario, currently working with the City of London in the UK as well, running their London Cycle Hire network. So we learned a lot and we know a lot about smart cities and the problems of it, how to manage assets, how to go through and implement work order management systems, how to go through and connect all of your buildings into an integrated network environment. From all of those learnings, we're going to share with you some of the things that we've been doing. And what I'd like to do is go through what we're going to talk about today is talk a little bit about Ryerson and some of the work we've been doing on a campus environment, which is a mini city. So campuses and universities across Canada, if you go onto them, they're almost like the city. And some of those smaller cities, they're definitely the same size. We're going to talk a little bit about some things on the quick wins and what the cities can do. We're going to kickstart your project, and we're going to talk about some of the opportunities that we have available for you today. But who are we going to hear from? So we're a vendor. We do services. But what we thought we'd do today is bring along one of our experts. So Jenn McArthur is here with me today. Jenn is a researcher at Ryerson University. But the part I really like about Jenn is she's an engineer as well, and she came out of the industrial segment. I mean, she's been out there building buildings. And part of that is it's not just then the research problem, but how do we apply this and how can we actually make cities and campuses smart? So those are the things that we're going to share with you today. Myself, I come at this from a different perspective. I've worked with many organizations in the Lower Mainland, as an example, City of Surrey, City of Vancouver, Maple Ridge, Pitt Meadows, all sizes, Kamloops, and all different size organizations and all the challenges that you run into in trying to go through and manage the IT systems, but also the operational technology systems, the GIS environments, and then how to use all of that and all of those data sets to get value from it and to make your city smart. Smart city initiatives over the years started out way back in the late 90s and early 2000s, and we're about 20 years in. But with the advent of IoT devices, we're finding a lot more adoption of new streaming technologies and the ability to use big data analytics to help you as the basis to make your city smart. With that note, I want to turn it over to Jenn and let her talk a little bit about some of the things that we've been doing with and what she kind of sees and the problems she's seen and the solutions we've been working on.
Great, thanks, Mark. So I want to start us off with a story. So back when I was a brand new academic, I went and I did what I thought was a really useful project for Ryerson University. I talked to the sustainability person there. She was really keen. And I went and I presented my results to a lot of rolling eyeballs from a lot of building operators and management staff. And I just was not addressing their needs. Fortunately, the facility engineer came to my office afterwards and said, listen, you kind of made a bit of a fool of yourself in there. You didn't really know what you were doing. You're not answering the right question. I said, well, what's the right question? And he said, I get 100,000 reports, alarms, and miscellaneous action items every single year that comes across my desk. And that's a low number. If you can tell me the 5 to 10 a day that actually need my attention, I'll be your champion and you will have my undivided attention. So those were my marching orders. And we were saying, because when you look at it, when you look at cities especially, but even down at the campus level or the building level, we generate enormous amounts of data. And the goal that we're trying to do, and the project that we're talking about today, is how can you sift through all of that data and actually use it to benefit you? And how can you use it to actually be smart? And there's an enormous amount of data that already exists for your cities. And this is what we'd like to actually walk you through and see what some of the opportunities are. So let's talk a little bit about this project that we're working on. So Fuse Forward and Ryerson are doing a 5-year project to develop an intelligent campus So we've come up with a long-term strategy. We've created a data model. We've created some data streaming and fusion algorithms to actually bring on all of these legacy sensors from all over our campus, along with our computer-aided facility management systems and all of the other miscellaneous information that right now is just being trapped in its individual silos. And our goal is to create a single source of truth for all of the campus information. These are the things that are going to be capable of detecting and identifying those 5 to 10 critical things every day. And we're pulling together buildings, infrastructure, and transportation systems. So this is very multifaceted and starts to approach some of the complexity that you'd see with different kinds of city systems working together. A little bit about Ryerson. For those of you who haven't been to our campus, we are situated right in downtown Toronto. And our identity is very much an urban campus and city builders. We're very interested in research, but we are just as interested that that research actually be brought to bear to make the city that we inhabit and other cities better places. So we really do have this broader focus at actually looking at the urban environment. So what are we doing at Ryerson? What's the end goal? The end goal is actually to create a digital twin of the entire campus. And what you see on your screen is our proof of concept, which is the first really complex digital twin. Now, over the past few years, we've already created a virtual campus model of the 66 buildings on campus, housing 50,000 students, hence Mark's comment about this being, on par with some, population-wise at least, of some of our smaller cities. And we've used the Daphne Cockwell complex. This is a fairly new build. It's 28 stories, about 300,000 square foot. The first 8 stories are an academic podium building. So this is all labs and student study spaces. And above that, we actually have a mechanical penthouse and 20 stories of office. What you see on the right is we've actually created a live digital twin in Forge by Autodesk, where we can actually interact with all of the data that's been streamed from all of these different systems. So we're using building automation system data and using it as a legacy network of sensors. We're using Wi-Fi data, and we're using all of the facilities management systems that they've unlocked and opened to us to be able to bring that data in. We're also installing new sensors all around the campus to be able to really complete that picture and try and address some of the issues of the missing pieces that we have. Now, as we continue in our development, we're going to be creating new event detection algorithms and new ways of actually predicting what's going to happen in the future. And one of the ways that we can support that is with Ryerson's new Smart Campus Integration and Testing Hub. So we were one of a handful of projects funded by the federal government this year. So we've received money from the Canadian Foundation for Innovation, and we're going to be building the world's first 100% digitally enabled building. So this has a smart office mock-up, it's got a smart home mock-up, and it's also got a data center where we're actually going to be able to stream the rest of the campus information and actually engage with the digital twin and continue to develop that research while also streaming all of the data from this facility to be combined with data from other facilities between our Network of Living Campuses project. So really trying to bring together a lot of these sources of data. It's a very ambitious building. It's a mass timber structure with wood from sustainable and First Nations managed woodlots. We're aiming for net zero in both operation and construction. And that, based on a call we had with the design team earlier today, it looks like it's going to be happening. We've got on-site solar, electrical and thermal generation, even in a tight downtown space with a lot of shading. So we are really looking to demonstrate what can be achieved. And this is just part of how we're going to continue to develop this research. And it's not just smart buildings. We do have kind of a smart grid that's integrated there. And we're looking at smart transportation, both the occupant and pedestrian flow modeling, as well as kind of the traffic modeling around. So this is part of this same smart campus integration platform work that we have. So if you step outside the building, you can actually start to think of some of the things that we can do with some of this data. So how do you actually look at how people are moving around? Next. So there are projects that we can do. There are ways that we can actually take existing Wi-Fi data and actually figure out how people are moving around.
Back one.
Sorry, there was a
Wrong way,
freezing
Carla.
issue. So I clicked next quite a few times. Apologies, Looks like
We got to go back to the mobility slide.
Yeah.
All right. So let me just talk a little bit about this. My colleague Bilal Farouk is actually here in this room. He's the one who led this project, so he's certainly the expert. I'm going to try and summarize it quickly. So basically, one of my concerns as a mechanical engineer is how can I be aware of when my building might have a peak load? If I'm trying to do demand response and I'm trying to, adapt for the fact that I'm going to have 500 students coming into a classroom, I'd like to get a sense of where these students are coming from, how many of them are on their way, and when I can expect them, especially when I have large patterns of students. And you can use Wi-Fi sensors that actually just look at the MAC addresses. So if you take the phone, it doesn't give any personal information about me. It just gives an alphanumeric code that's unique to me. Now, I can throw it off a little bit by having more than one device on me. I could also throw it off by having my location off or not having a device on me. And there's other ways that we can actually reinforce this data, whether it's with people counters that doesn't actually violate people's privacy. But it gives us a sense of how people travel. We can get a sense of how our individuals are traveling on foot, and this has been used for planning city events, planning how you're going to be managing large crowds, and basically designing better urban spaces for the public. So this is just one of the many types of existing data that we have that can do.
So let me build on that for a minute here, Jen. So give you some little practicalities on the city side. If you think about human mobility, if you think of all the economic development opportunities, especially in the COVID recovery, we're trying to go and figure out how to go and help restaurants to stay in business. And one of the key things we start looking at is, can we understand the human mobility transportation pattern? So as we look at it, I live in Vancouver, I live in Kitsilano, I walk everywhere. But what we're really trying to understand is, how do we go through and are the new sidewalk restaurants where we're blocking off the parking spots and putting restaurants in place? How is that going to help us when we're going through and dealing with mobility? Can we use some of the data that we have and some of those transportation patterns to actually go through and do that? Those are kind of some of the opportunities that we have with respect to human mobility and occupancy tracking. So it's like all of those data sets, we have them. We have transportation data coming in from the traffic flow counts, but those data sets are available. And as we start collecting them, it's more and more. It's like, how do we just go and understand the patterns of use? So those are some other ones that we see. And then the other one, of course, is on human mobility as well, is what about train stations and bicycles? And as we start seeing that, some of the work we're doing with the City of London is understanding how people use bicycles when they come in off and get off the train, and where do they go? And we actually have bike clicks, and we click them in and click them out. We put GPS on each one of the bikes, and we're able to go through and monitor how they're actually moving from train station to home, and then we move the bikes back. Those are some other areas of human mobility.
Great, thanks, Mark. The next project that I want to look at is, how can we actually take city scale data from a variety of sources and bring them into one common context? So the Toronto 2030 district worked with the City of Toronto and our three major utilities. So that would be Toronto Hydro, Enbridge Gas, and Enwave, which is the deep lake cooling, to try and figure out how to actually map out this district. Now, this is 1/66 of the city in terms of area, or about 2% of the city. So it's 2% of the city of Toronto, I think, is still nothing to sneer at. Fairly significant population. And what we did is we took the GIS data for the city. We took the property assessment data from MPAC and from other city records. And we actually bound together aggregated city water and utility data so that we can actually get a sense of what was actually happening on a block by block level at the city scale. There's a few reasons that we wanted to do this. First off, Toronto Hydro were really interested in trying to get their consumers to drop their energy use, but they wanted to make sure that they weren't going after people who had gone and decreased their carbon emissions by getting rid of their natural gas boilers and switching to green heating. So they wanted to know, with their high power, high electricity users, low gas users, and that was one of the reasons they seemed to be on the bad list, but actually they were probably one of the best contributors to reducing greenhouse gases in the city. Another big question we had was, the City of Toronto had ambitions, and they passed their first document this summer to get to net zero by 2050. To do that, we need a roadmap, and we need to know where to target. So what we did is we actually created this platform where we took all of this block level data, and you could actually visualize it. So you can see on this dashboard the high level view, but if you actually click in on particular blocks, you can actually see any particular block, you can see its greenhouse gas emissions. You can see particular buildings on that block. Now, we're not disclosing the individual building emissions because that would violate the data sharing from the energy disclosure, but it does give us a sense that you can actually see how these buildings are being, like, if you have particular blocks or particular areas, maybe they have a very high heating demand. Maybe they have a very high cooling demand. Maybe it's an area that would actually benefit from an expansion of service by one of the utilities, or an area that might have the possibility for cogeneration or even for waste heat recovery actually having some future benefit within that space. So one of the things, and just one of the important things about this is that we created all of this to be replicable. So the Toronto 2030 district has actually made this such that we could replicate in other cities. And it was actually my team. If there's a benchmark you're building where you can actually go in and actually see how your building compares to the other ones in the city. So there is a sense of kind of being able to dive in. Sure, that Mark, you had something to add.
I was going to ask you a question. So what if we were to go through, you've got in here that we're using water consumption. I know some of the projects I've done in the past. But what if you think about this? I mean, I know what we've seen already in the way of doing hotspots and everything else. Can you share with us some of the ideas you see and some of the research on how we could take that same map, look at the building emissions, and create hotspots and cold spots? Look at thermal imaging. Share with us some of your ideas around that.
Well, absolutely. So some of it is you could, if you, to the extent that you had sensor data, you could always definitely put that in. You can do urban heat island effect, and you can get a sense of where the city might want to invest in more green spaces, because green spaces are a great way of decreasing these local heat islands we have in very highly built up spaces, or maybe cool paving technology, cool roofs. You could look at kind of places where you have simultaneous heating and cooling. One of the reasons we did the benchmark your building is we actually adapted the published archetypes for different reference buildings to Toronto based on the actual utility data. Because a lot of the ones that we have are either based on the assumption of code performance or they're quite old. The models that live in this basically simulation environment, let you see how those buildings are working. And based on the clustering of the buildings, you can get a sense of where you have high heating versus high cooling. And then you can see where you might have the ability to save heat or reject heat. There's heat pump systems, not to get into too much, mechanical engineering nerdiness, but heat pump systems basically let you take buildings or heat from buildings that are overheating and need cooling and bring them into places, whether they're swimming pools, whether they're community centers, or whether they're simply buildings that need cooling or need heating at the same time. And you can just transfer that energy. So you don't need to run a chiller, you don't need to run a boiler, and you're just moving heat from where you don't want it into where you do.
So looking at our audience, so here, let me see if I can summarize a few things based upon my municipal experience. So one thing about our audience here, you guys have already, you folks already have all this data. So right now in the water utilities that all these municipalities run, the wastewater utilities, the transportation groups in the public works departments, we have a lot of this data already, and we're using more and more metering infrastructure, both district flow meters and everything else. And you can start going through and just overlaying this on top of the maps, which you might be doing today. But there's a lot of things now by looking at those specific use cases. And a lot of that technology that I'm seeing up on those screens is readily available in the cloud environment and easy to overlay. So it is, when we look at the time window to go and do a little bit of a project here, it's not years or months. It may be about 8 months, but that's mostly curation activities. And we can talk a little bit about that as we move forward. But just think about this for all the people in the audience. What data do you already have? And then how do we go through and do this showing? And then what Jen was just describing is typically through the property development department. It's the planning department that basically has the needs to look at this. And then they're the ones that are usually talking with the engineering department. So moving on, appreciate that. How's that so far?
Yeah, it's great. One of the other things that we've built in to be able to this as well is actually looking at upcoming developments and being able to predict what kind of load that it's going to have on the grid, and also whether there's potential or whether it would be valuable for from a city planning perspective to actually try and plan or incentivize the creation of particular developments. Say a community center that does have a pool in a place where the heating of the water for the pool will actually always be of net energy benefit to the city, and actually address it that way.
What else we got? We got some more ideas here. I know
we do. So if we look at tracking city service issues, now this is something that we've got deployed at Ryerson at a relatively small scale, right? It's just to 66 buildings. But we had this question of you have a variety of sources. So this is just one department. It gets infinitely more complicated with the city, but I think the benefit becomes that much easier as well. You have people sending emails, you have people calling a help desk, you have people interacting with a web portal, complaining about particular issues, describing events that have happened. So you have all of these different city issues that you're trying, or campus issues that you're trying to resolve. We've developed some algorithms that lets you classify it, lets you map it, and lets you actually visualize it over top of the actual, in our case, the campus, and then zoom into the building scale. On a city, it could be the city, the neighborhood, the block. But there's no limit to the kinds of things you could visualize. You could look at different kinds of crime, and as some cities are looking towards more community-informed or social work-supported policing, you could actually identify areas where it would make the most sense to pilot that sort of project, or to increase the number of kind of non-police staff who could actually respond to particular incidents. You could look at places where there have been issues with access to water or basement flooding, or any sort of other environmental issue where you can actually target, say, whether it's remedial services or increase maintenance funds to where they're most needed, or whether it's actually fairly large projects that need to be planned. And there's this idea that, like, within the absence of information, you might invest equally across the city. With the right information, you might recognize that some neighborhoods of the city are very underserved in other places and need more investment, and other areas of the city are underserved in other ways and need other particular investment. So this is, again, probably hundreds of different systems within the average city will create data. And how can you map those in? How can you navigate them and create these interactions? And again, we can create these dashboards fairly quickly from city scale, the same city scale data that goes on the previous dashboard, but actually use that to create a different kind of hotspot, not the literal thermal hotspot, but much more in terms of areas of key concern where city staff can really target their efforts.
Perfect. So one of the things I always look at with city services, I'll be honest, is where's the garbage? And do we know how many garbage pickups we're going to have? So I think one of the things is did the city miss it? And if you think about some of this in the way of the future and thinking forward in the way of smart, if we have the method, and what we're starting to do is track every single device with a sensor on it. And even our garbage cans can be censored. And we can start looking at them and saying, okay, now has the garbage truck missed one of the streets? And we start looking at our garbage collection routes. And then I used to live in Ontario, and I remember Ontario, and we used to go through and have the snowstorms. And it was like, if you do not have the snowplow coming down and they forget one of your roads, you're stuck going and clearing your path yourself. So there's always ways to go through and look at all of those transportation patterns and using that, and basically able to use new IoT sensoring technologies to do this. But remember, your data is already there. A lot of the technology we're talking about, the data sets are already being collected by the operating systems. So we create some methods to go through and make sense of it all.
Yeah. And then you could also use this to kind of build out new apps for actually engaging with some of the city services, some of them that could be AI enhanced, so that you could very specifically try and collect data from people while they're reporting something. In our case, we were having people go to site 3 times because the person reporting the issue didn't give enough information. And if you just had a knowledgeable person on the phone who knew the right questions to ask, they could actually get the right information the first time and resolve it that much faster. Well, we've actually created a bot that's capable of doing that. And that could live on an app that also had your ability to rate the city service, to give you feedback on how well the city's addressing things. One of the big challenges you have is nobody ever tells you you're doing things right? Yep. You only ever hear, when we have our dashboard, we call it the occupant dissatisfaction dashboard. Because I don't think there's a single complaint in the database that said just wanted to say everything's fixed, thanks so much, right? That doesn't happen. All you get is the ongoing complaints. So this would give you a chance to see, where have things gotten better and where are things actually progressing? Because that's the whole point of making your city smart, is to actually use the data to find those critical things that you can do, those 5 to 10 a day, that help you to really meet the needs of your citizens and your taxpayers and the people who you're serving, so that you can actually make their experience in the city better. So the last thing is really talking about scaling this digital twin. So as we've been working with Fuse Forward, one of the key outcomes that we're trying to work for is not just to create a digital twin of Ryerson campus, because that's of limited value, but to create a sense of tool, like a whole set of tools that can be rapidly redeployed. so that what we're actually able to achieve at Ryerson could be replicated, across the country, so that those of you on this call could actually very specifically benefit from the work that we're doing, and we could actually redeploy it in, right? Most cities have digital models, these GIS models of the city, whether it's run by planning, whether it's based on a particular project that's been done. You can also do drone mounted cameras, and you can do that with hyperspectral imaging to actually get a sense of this heating and cooling, or these heat maps and the relative temperatures. You can do it simply with a regular LiDAR camera or with photogrammetry. And you can create some fairly elaborate models, and the cost of doing that is dropping significantly. But basically, as soon as you have this digital twin of a city, you can start to run scenarios. You can start to run these what-if analyses. You can look at how much time would it take for, if there's a new development, how much time would it take to get there from all of your existing EMS stations? Where would you need to place the other one that you could actually run it and get a better sense? And what else would it make sense to include in that immediate area? What else should you be incentivizing your developers to provide, or requiring them to provide, to try and address maybe some other issues that are in the city? And you can actually run different tests. What if we added this? What if we added that? And how might that affect the various city services? So this is really a chance to not just collect the data and visualize it, but to actually be able to run simulations and actually test out these what-if scenarios.
So I think one of the things I'm always thinking about decision support. If you think about the skit hub that we're building, think about the ops room. What do you envision to be up there? If you're looking at the Ryerson as a smart campus and as a mini version of a smart city, what do you think they are for your facilities client that you were talking to with that 100,000 questions? What do you think would be the top 5 that he would want to be going through and seeing inside that control room?
Oof. Well, he was giving me even specific things. Do I have critical equipment that I need to do preventative maintenance on and prevent an expensive failure? That's a question he couldn't answer, but it's a question that our research is aiming to support. So kind of what's the critical preventative maintenance that I need to do, right? I'm getting a lot of nuisance alarms, which look like nuisance alarms, but aren't, and could actually be hiding a real problem, right? Where are places, where is the one corner of campus where we need to be actually deploying our team, because this area is flaring up and it seems like there's some sort of root cause that's causing everything. We need to get down, and we can't tell what it is from the data that we have in our system. But if we could look at the 5 other systems that are managed by other people in my department, then I could start to get a picture of it, right?
So it's what we call bringing all the data together in one place, single source of truth, as you called it, and trying to put it all together. Well, what I would like, perhaps what we can do is let's talk about how you get started. And by all means, Jenn, as I'm going through this, feel free to jump in, just like we've learned to tag team and share our knowledge as we go, and I think we enjoy doing this. But let me share with you some of the stuff that we've kind of been thinking, what we do and how we kind of approach this. I started as a consultant back in the I'm going to date myself, but the late 80s, okay, working on complex pipeline systems for oil and gas companies. That knowledge transferred over into municipalities with their water, wastewater utilities, their transportation systems, and everything else. That knowledge also transfers over into going through and managing bicycle networks. But one of the key things that comes along with all of it is there's some fundamental technologies changed over the years. It started out with, for all the IT people in the audience, DBase 4. And then we went into a thing called relational database, which is now called Oracle and SQL Server, etc. And then we started to move into this whole world of big data and big data systems. So that's the technology paradigm. Okay, what we've started to do now is that stuff is all there, but it's tech, and that's how to store it all. But one of the key things is all of our different systems sit in different places. And one of the key things we look at is how do we collect it all? So that's kind of step number 1. Can we collect all of that data from all these disparate systems? The second part of the steps is how do we curate it? And I'm going to get into each one of the details of this. But curating, what does that word mean? It means making sense of it. It's normalizing it. It's what we call, and I'll talk a little bit about to this, but it's about putting tags on it. And then the third piece on it is a lot about consumption. And consumption is by the end user, by an application, by a control system. It's all the different ways that we need to consume that data once we've curated. So let's look at some of the details of that. So the collecting part, identifying the data and organizing and structuring it. So, I always ran into this problem. And I always looked at it and said, I've got all this metering data coming in, but it didn't have the right decimal points on it. Or like when we go to the gas pump, is it all normalized to 15 degrees C so that we can understand the volume calculations properly? That is a lot of the collection process. It's what we call normalization, and it is basically mapping it to an industry standard if there is one, or it's also creating this whole concept of what we call ontologies or taxonomies. Okay, creating these labels that we can attach it to so that it can basically be mapped and compared to it. So in the municipal context today, we have an initiative underway called the National Benchmarking Initiative. It's for going through and calculating and comparing the cost of a liter of water to be delivered to a household compared to other utilities across Canada. All right, well, part of that is well, what are all the different systems and how do we understand the different pump stations and how the pump stations would be in place to go and measure the cost of running a typical pump station that's running X volumes of liters of water through it at any given point. So that becomes a measurement point or a taxonomy that we can start defining in the way of flow meters through these. That's all part of your collection process. You might sit here and say, well, that's really complicated. How the heck do I do that? Well, guess what? We just spent 2 years working on this as part of a research project, okay? And Jen could talk to that, but it's really the whole part about how do we go through and map this into common ontologies. And what we've been doing is publishing those. So guess what? There's people out here already trying to solve the problem without you having to go through and do it from scratch. And we're publishing papers on that every day. That's collection. It's around getting billions of data points from all of your different systems, putting it into a repository and being able to make sense of it. Now we curate it. All right, so curation. When I look at curation, there's an interesting question because we did a project for a restaurant chain and we got 3 years of data. And we brought all this data in and it was on every single purchase by every single customer and every credit card transaction. Well, that's collection. That was the collection process. And we sat here and says, well, how do I go and figure out what the average, how can I predict consumption by the customers and figure out who's going to arrive on what day and how much they're going to spend? So we were given that problem. So the only way that we could actually do that is by creating key performance indicators. Key performance indicators, we had to create a context of an event called something like a table visit. Well, everybody goes into the restaurant, so you know what a table visit is. But is a table visit a single person, or is it a family? Or is it when 10 people to go together and create a group? What is a table visit? So we had to start defining that context and all of the other key performance indicators around it. Because a table visit could have 3 bills, not one. But it's a table visit. They all came for one purpose together to go and watch the football game. And it could be 1 bill, it could be 5 bills, it could be 10 people, it could be 3 families. But they came for that event to watch the football game. Okay, in Canada should be hockey. Okay, so we created the context. Everything I'm talking about there is curating the data sets. So what we're doing in the curation process is we're creating indicators around events. Why is that important? Because once you have the indicators are the things that we start doing forecasting on. We actually don't forecast raw data. Raw data are logs, okay? But they have to be normalized. So we get that data, but we eventually have to put the logging data, all of those flow patterns from water meters, all that electric consumption information coming from an electric meter and from a circuit, all of those people moving around the city, all our events are our readings, but then we got to create an event around it in order to go through and forecast it. That's the curation. So now we've got all of this stuff, we've got all these events, and we've got all of these different kinds of things together. Now we've got to go through and say, well, I look at the operator that sits in an operations room in a water treatment plant, or somebody that's a facility operator sitting in a room and trying to run a campus. And they usually have 11 or 12 different dashboards in front of them and different monitors for all the different systems. So what they're really looking for is a consumption environment, which is a single unified pane of glass. But one of the things that we've also learned is that they don't want 1,000 alarms or 100,000 pieces of data. They want those 3 key pieces of indicators, and they want them to be flashing red, yellow, or green. And when they're red, they want it to go and they want to start looking at it. When it's yellow, well, depending upon whether there's any red ones, they want to go and investigate a little bit. But they always want to have a decision support tool which gives them already pre-optimized options. They don't want to be looking at 1,000 options. They want to be looking at 3 or 4 recommendations. And we're never going to get rid of operators, but they need help because the amount of information coming at them is all consuming. And you could be spending your time analyzing as opposed to doing. When there is something coming into a water stream and it's got a contagion in it, we need to have that alarm go off and we need to turn off the systems quickly. Okay, that's the part of the consumption. So it's that autonomous control that goes with it. The other part is just giving the dashboards. It's like, let's look at how many people are actually going to the restaurants and whether we should be running more buses in that area. Let's see how many trains are arriving, whether we should put some more bikes at the train stations so they can ride home. Let's go through and look at whether we're going to go and have another football game or a soccer game. I'm a soccer fan, down at the stadium, and whether we need a bunch of Ubers and Lyft drivers and other kinds of transportation patterns around that. And that's the consumption side. So it's all of those different ways to go through and allow us to use decision support tools, but creating the big buttons. Okay, I'm a mathematician, so I thought it was like, well, I can go and create these great algorithms. But you want to know, most operators don't want 1,000 algorithms. They want curated 1, 2, or 3 different options that they can select from, and they'll manage the risk, but they need help to understand the data. So there's your 3 steps. Okay, now it is really that simple. Like you might sit here and say, oh my God, there's a lot of project work to do in this, but remember I talked about the technology and the fact that I started in 1988 doing that. Well, in fact, I wrote my first software application when I was in high school, and that was about 1980. Ooh, gosh, no, that was in the 70s. Okay, and it was on a PDP-11. All of that stuff there, we have created these amount of libraries of code that are available to plug and play. So we can do a lot of this work quickly now in order to go through and just plug components together. That's the value of what is available now with new systems evolving, and we start looking at it. But really, the challenge now is to make sense of the data sets that you already have inside your municipality. Okay. So let's go through. I always look at it, and then, of course, because I have worked for munis for 25 years, 30 years, I'm dating myself. I always sit here and say, but we don't have any money. And I'm like, well, guess what? I can tell you where all the money is. And Jenn and I we've got this down to an art, I think, now, because we have been through so many funding grant applications together. We've been turned down so many times, but we got perseverance. So we've figured out exactly how to go and get it now. But let me talk to you, because I think this is important for everybody to understand. There is money available. We also have a new government as of Monday. And that new government has a whole bunch of funding programs that has always been available. In the municipal world, we have city funding envelopes. And what are those? Well, that's things like the Federation of Canadian Municipalities, the Green Fund, infrastructure grants that go specifically to municipal programs. You might sit here as IT folks and IT professionals say, yeah, that's only available to the utilities. Well, actually, it's not if you structure your projects correctly. So there's ways and arts that we've come up with on ways of going through and figuring out how a project can incorporate the big data and control system element coupled with some of the infrastructure spend. So if they're going to go through and build a new building, they're going to go through and build a new water treatment plant, there's a whole bunch of the IT systems that can be incorporated in with it, including pilot projects to do that. So that's a funding envelope available today. Second one is research funding. So research funding are usually government research programs, and I might be talking to people that know some of these already, but you're always having university researchers knocking on your door and saying, hey, will you guys work with me to sponsor some projects? And I mean, we've reached out, we've worked with Ryerson, we worked with SFU, we worked with UBC researchers, we've worked with BCIT locally, because this is BC, okay, but we've also got the ones out west or out east, and the ones even further east in the way of Dalhousie as well. The research funding comes from National Science, Engineering, and Research Council. It comes through different programs like MyTax, okay, which are all research funding that pay for students. But these are really smart people. Okay, so even though they're paying for the students, what they get is they get Jenns. They get the Jenns of the world overseeing all of these students. And that means you get the value of their time, you get their PhD candidates and their postdocs. You also get their master's students, and you get to combine them in some cases with polytechnics like BCIT, where they actually develop software and applications for you as well. The key question is, what's the problem? Is there a solution? Is there a demonstratable project that can be done? So all of those projects that we just described are all research funding eligible. That means that you can go through and tap into some of the research funding to do some of those demonstration projects.
Yeah.
Some of the things we're doing on that are things like the living labs and creating living labs. Jenn, you want to jump on that one? Because I know you are very experienced in this one.
Yeah, I think there's different nuances to all of this funding, right? City funding tends to be much more on city projects. The secret sauce, as it were, for research funding is you need to demonstrate there's a scientific or technical challenge that has yet to be overcome. That's the barrier. That's the difference between research funding and, say, like an innovation funding, where maybe the base science, the fundamental things exist. So when we've been working with Mark, it's, the ontologies didn't exist. Certain centrifuge and integration algorithms didn't exist. We're doing smart and online commissioning and fault detection diagnostics and some complex event detection. Those are based on, we're developing new scientific principles and kind of new applications and new ways of doing things. And that's kind of the distinguishing factor for, say, a research funding grant versus some of the other ones that Mark will now lead you through.
Exactly. And you want to know, this is the beauty, because what we actually find right now is with the research funding, there's usually a lot of the research agencies are looking for now is that there's an industry partner coupled with it as well, because they're looking to go through and find a way to commercialize that core research. And that's the strategic partnership we have with our university partners, and Ryerson being one of our anchors. Okay. The innovation funding is another one. And this innovation funding is things that industry is usually chasing, but we do it in partnership with local governments. We do it in partnership with the universities. And we usually bring other small and medium-sized and large industry partners all to the table, like engineering firms, okay, IT organizations, and the SCIT hub that we are building with Jenn at Ryerson has got probably about 12 to 15 organizations in it, mostly industry partners, all contributing in-kind time, okay, and in some cases technology, and in some cases cash. But what the innovation funding does is it augments that. So it's a dollar for dollar type, I'm using rough ratios, basis. So as the industry partner goes in and contributes, the government will contribute the corresponding money, and that gets us to a different level of technology readiness. So it actually helps us at a different stage. So what Jenn was talking about under research funding is usually at a pilot or a proof of concept mode, what we call lab-based proof of concept, whereas the innovation funding envelopes are usually taken to pilot in the field projects. Okay, much more, getting a little bit more mature. But they're usually done with an industry research partner like Fuse Forward. The research funding is usually done with an academic partner like Ryerson, BCIT, et cetera. And the technology, and then the fourth one in this other one is the technology funding envelopes. And technology funding is from some of the large corporates, like I'm sure everybody is using, I know that different universities use things like Esri software, that's academic partnerships. Those are all available for technology funding envelopes. And we basically have a whole bunch of other issues or other funding places that the industry is willing to go through and contribute in things like, we want to help with sustainability projects. So they have funds available to go through and do community-based projects. And those are coming from the technology or the industry partners themselves. So there's all of these different envelopes. Now you might sit here as a municipality and say, oh my God, I can't navigate all this. So what we kind of have been doing is creating, and this is, I'll give a little plug for this one, is we've created the Intelligent Systems Alliance. And what we do is we take on the task of applying for the funding envelopes, so long as some of the industry and the city partners are willing to be a site for it. And then we take care of putting the envelope, putting the grant applications together and basically working through that process. Okay, but how do you get started now? So Carla, if you want to jump down. So that's kind of the money. And I always think about it, it's like, before I jump in and say, let's get started with the Smart City solution, I want you to already know that there's money available to do it. Plus, there's a whole bunch of smaller projects that you can start with. But how do you get started? It depends upon where your city is at, okay, and your municipality. Are you ready to go and whole hog take the whole thing on? Is your council ready? Is your city manager there? Is your engineering department and planning departments on site? Do you have your facilities organization all in place? Is everybody willing to go and participate? Well, that's city scale. That's number 3. Usually that's a very significant initiative, but it takes time to get there. So we always like to go back and start off with POCs, proof of concept projects. Basically take a small little area, take a single pump station, okay, and work on it. Create a digital twin of the pump station, suck in all the data, come up with a way to go through and optimize and manage that pump station. That's a proof of concept, okay? Then as you move, you can also get into another one, which would be something like a pilot. Is there a way to go through and basically look at a water distribution network, okay? Or an area within the city which has the water distribution and wastewater, and you overlay them on top. We did that in Ontario, one of the cities, okay? So those are pilot projects, and we have different ways then of creating those ones. And then as you start learning and moving across, you can get into scale. And those are the different ways of getting yourself going so that you're not biting off everything. You can start with small readiness, and you got an organizational department that are ready for it, and not trying to go through and basically what we call boil the ocean. Okay, start off small, get it going, prove success, get some data in, use the replicatable technologies that are already available today right off the shelf, and use those pieces to get yourself going. Now, one thing I want to do, Carla, share with you, you're struggling to get going. So we have some partners that are willing, and through our technology funding methods, we have available right now for anybody interested, or for people that are interested. We have limited availability. We have about 4 of these programs available that are already pre-funded. We've got some funding support already in place and lined up to do a couple of half-day workshops and help to define some of these small little projects. Okay, figure out if there's a way to go through and get going. If you're interested in looking at this or applying for one of these free engagements, please, you'll see, stay informed there. And I think Carla will actually go through and on ours, we'll basically provide and share with you a link on our website so that you can go through and register, and we will talk to you and see if you've got the readiness available. And we have 4 of these options available to you today. Okay. On all that, I see a couple of questions coming in right now. So we have about 12 minutes left. Why don't we go through and answer some of the questions from the floor?
Sure. And sorry there, I clicked ahead a bit quickly. I was trying to share my video, but I'm going to read these out for you. Mark, there's a couple here and they're on the same topic. So I'm going to start with that. Sidewalk Labs gave up in Toronto due to privacy. Do industry partners want data as part of their involvement with such projects? And how do you manage privacy requirements?
I've got to answer. Well, Jen, you've got some, but I've got some other pieces, because there's definitely, we think of privacy by design.
Yeah.
Okay. And the whole part here is while there is a desire for people to use the data, it is privacy and security by design. And we are not looking, people do want access to the data, but it's going to be anonymized, it has to be privatized, and it has to be locked down in a private environment. Okay, and it doesn't get copied, it doesn't get consumed, and it's not for advertising, it's not for any other purpose. But that was one of the key things, and we did watch that very closely, and it was like, the agreements that were being thrown out are not those kind of data sharing agreements. I know Jen can talk to this. We are with part of the Skit Hub right now, working on data privacy agreements and data sharing agreements between them, but it is not the approach for the side from what Sidewalk Labs was driving. Sidewalk Labs approach, I don't know, Jen, maybe you can talk to it a little bit better than I can, but I watched it and I was like, yeah, that's not going to fly.
There was a lot of personal information being asked for. And we found, actually, to be honest, even in the whole Smart Campus project, we've been able to do the whole thing without actually collecting personal information. And part of that is Dr. Ann Kabukian, the Privacy Commissioner of Ontario, who made world headlines for really cracking down on things like Facebook and some of these like online privacy violators. She's an adjunct faculty at Ryerson. I actually sat in her office and we actually spent an afternoon talking. This was back in that 2030 platform days of how do we create these cookie jars where you can put in data so that you can only ever take out amalgamated data that actually protects people? What do you have to strip off of the data? And how do you have to redact your data sets so that you're never actually sharing information that would actually trip, say, FIPA, right? Or any of FIPA or any of these sort of privacy regulations that actually impact what you can and cannot share, what you can and cannot disclose. So I think if you take a careful eye to what's going on, typically if you're not actually retaining and analyzing people's faces, if you're not taking and retaining names, date of birth, that kind of personal information, you actually tend to be fairly good. Sidewalk was trying to do a lot more invasive and actually tracking individuals moving around. Our data is much more focused on the bulk movements because it's not necessarily the individual snowflakes that you're concerned about when you're trying to manage a service. You're really concerned about where the avalanche is going to hit and making sure that you're actually prepared for it. So as soon as you start kind of getting, once you get to the aggregate based, privacy actually stops being an issue. It's only when you can actually predict when a certain person will be in a certain place at a certain time. And that was unfortunately a line that started to get crossed, or the implications that was going to get crossed in Toronto. And that's what tended to scare people off from what I saw in the meetings that I went to at the city for that.
So some of the other things, just to kind of augment that, is when you start thinking about this and you say, well, I still want to understand human mobility patterns. One of the things that we are currently researching and trying to determine is how we can use agent-based modeling, simulators, to go through and simulate movement patterns. Now, part of that is you've got to still have some real-world patterns or analysis to go through and help train those. But you can do that at an aggregation level to help improve your algorithms, and that helps you to go through and create those simulators. And I always like it. I think Jen and I have always been working on this concept. We're trying to create a real world Sim City on steroids. Okay, and that's kind of the working mantra we have for these digital twins. But it's basically going through and saying, you know, I need to go through and have some representative agents inside this virtual environment to basically understand the flow patterns, whether that's flow of the virus through a air conditioning system, or whether it's the flow of people into a coffee shop to go through and get their morning coffee. Okay, it's still those same sort of things that we look at, and we can use agents for that. Carla, any other ones?
Yeah, so another one it's an interesting one. What type of data tracking have you found to be the most valuable and has led to the most change/improvement for the public?
I think it really depends who's asking that question, right? I think if you're talking to utilities person, they'll tell you it's the insights they can get from utility and energy views. I think if it's a transportation person, it'll be transportation networks. To be honest, I think, and this is going to sound like the worst non-answer ever, and maybe Mark can give you something more specific, but I think it's the kind of data tracking that you need to actually answer the KPIs that matter to you, right? You could collect anything, but it's really a matter of we need to know what you're trying to do. You can't manage what you can't measure. And if you haven't defined what you want to manage, then you can't really identify the sources that you need. But having developed a series of these proof of concepts and these use cases, we do have a sense of what can be useful in particular aspects, but there could be 100,000 questions that you want to ask.
So
or,
so let me throw out some, because you come from the facility space, and I've done a lot of infrastructure. But if I think about it right now, let's think about this from a perspective of the building, of the tenant, or the person inside the space. And I remember we go into these rooms, and the one part is we actually have changed our whole office before COVID, and we put in localized HRV systems because we always have a problem. So what is the most valuable piece of information there? What is the current temperature inside this cubicle space? Okay, because certain people like it hot, certain people like it cold. And so in certain places, we want to understand what those flow patterns are in the turn on and turn off cycles, which means air temperature is one of the key indicators. So that's for tenants inside buildings. But if I am the water operator and I am the people that's going to be consuming it, what I care about the most, not water pressure, is contagions in the water stream, because that's the massive health and safety. So anything I can do there to start going through and improving the time to problem resolution, the better. So if I want to find something, it takes 72 hours to go through and get a lab to basically test my sample, and I can find a way to do in-stream processing instead, I want in-stream. Okay, and that helps us to stop and monitor contagions in water streams. Now, I'm going to take wastewater because one of the things I've learned is that we can actually determine where COVID is breaking out by analyzing our wastewater streams, okay? And basically, we can find out what communities have had it historically, and we can start looking at when it actually started coming in and what its pattern of flow is. So in that case, we want different kinds of things where we want to monitor what kind of viruses are in our waste streams. So it answers exactly to what Jenn just said. It all comes down to what indicators you're tracking in the area that you care about. Okay, yeah. So it's not an A or a B, or it's not an A or a B or a C. It says it depends. I hate those questions or answers when people give it to me, but I think that kind of gives you context. Understand your user, ask the key, what is the primary thing that they're going to be challenged with, collect the raw data, turn it into indicators, and then use it to make those decision support information.
And just to give an example from a wholly different context, one of my, a few of my projects actually before I became an academic were with the Toronto Transit Commission. And they, I think, are like a lot of, whether they're transportation or other service agencies, and their question is there something likely to happen today that's going to make it, like, that's going to interfere with delivering the services that we have promised the public? And that, I think, is kind of one of those fundamental questions that applies everywhere. For them, it was, what's the likelihood of a failure of one of our trains? What's the likelihood of the overheating of one of our spaces? What's the likelihood of some sort of communications issue that actually brings down, say, the signals that kept acting up at a station? So can we monitor things? Can we actually predict these major catastrophic failures before they happen so that we can actually work around it and prevent it? Yeah.
So on that lovely note, I think we've got any other questions, Carla? It doesn't look like it.
No, yeah. So I just actually want to jump in with something to add here, because I know there may be a few more questions that people have. So we actually regularly run a webinar series called Remote Control, and hopefully Serena has shared the link in the chat. But I just wanted people to know that next week we actually have a discussion session. So it will be Mark, it will be Jenn, and it will also be Roy Hart, who's leading the BCIT Smart Campus. And that's more of an open discussion where we do question and answer next week. So if you want to come along to that, if you haven't had a chance to ask a question, you can join us there as well. And please stop by the booth and say hello to us. We'd love to meet you. Yeah.
And we're serving espresso coffee.
Sure. Thanks.
Virtual, of course.
Yeah. Thanks.
Well done. Thank you very much, Mark and Jenn and Carla, for very fascinating insights to the world of big data and what you can use with it to make smart cities even smarter, and some good practical tips of places to get started as well. That's the wrap on this session. Our next session is actually going to start right away at 4 o'clock. So hopefully we'll see you in the next room. Thanks, everyone.
Thank you very much.